Hello, and welcome back to another lesson in pre-calculus. Today we're going to be learning about rational expressions and all of the skills that go along with those. So grab your notes, put away those distractions, and let's get going. First, we're going to work on defining rational expressions. So a rational expression. Rational is a ratio. That usually implies that we're going to do something with fractions. Expression means it's not an equation. So a rational expression is a quotient, i.e. answer in division, of two polynomials. So, quick question. Do you remember how to fraction? Because if you don't, this lesson is going to be painful. So, for a quick example, if we're going to simplify fractions, something like 12 over 15, let's see, what would we do in that case? Well, let's say 12 and 15 are both divisible by 3. So we divide the top by 12, that would give me a 4, and this would give me a 5. In general, the rule is if you have something times something over something times something, and some of the somethings are the same on the top and the bottom, the exact same, with no pluses or minuses, you can simplify that down and just kind of chop off that part and shove it off to the corner and kind of ignore it. Adding and subtracting. In order to add and subtract fractions, you have to have this weird thing called a common denominator. So our first one here, we do have a common denominator, so we can go ahead and add our numerators together. And that gives me 2/3. Real quick, it's numerator on the top and denominator on the bottom, just in case you forgot. But very rarely can we rely on our fractions to be kind to us and give us a common denominator. So sometimes we have to do a little bit of extra work. In this case, we have 4/3 minus 1/2, and we need to get a common denominator on these guys. So what we can do, the most surefire way is to multiply the other fraction, the one fraction by the other guy's denominator. I think that English is out right. There's more efficient ways to do this sometimes, but generally speaking, it always works. Sometimes you just have to simplify your answer. So that's fine. 8/6 minus 3/6 equals, I hate saying sixths, 5/6. Blah, blah. So generally speaking over here, you end up with dA plus CB over BD, and dA minus CB over BD. And I'm not sure why I wrote them in reverse alphabetical order. Typically speaking, mathematicians, we write them in the straightforward order. I don't know. It's just where I'm at today. All right, the next one, we're going to talk about multiplication. Everybody loves multiplication. Multiplication is the easiest thing to do with fractions besides simplifying them, because it's basically like unsimplifying them. What you do when you're multiplying is you multiply the top, and you multiply the bottoms, multiply the numerators, multiply the denominators. 1 times 1 is 1. 3 times 2 is 6. Or AC times BD. And we're good to go. Division is a bit more complicated. So division, in order to divide a fraction, typically the thing that I've heard students say again and again is skip, flip, and multiply. Typically what that means is you're going to take your first fraction and you're going to leave it alone. You're going to take your second fraction, you're going to flip it, or find the multiplicative inverse if you're getting all math technical, and then you're going to multiply those two things, which means we're going to multiply the tops. 1 times 2 is 2. We're going to multiply the bottoms. 3 times 1 is 3. And that's how that works. Now, we don't always get a nice little division sign in between things. Sometimes it looks like a fraction over a fraction, so like a fraction, or something. With those, just remember that the fraction bar, this means division. You can still do your division things to this, even though there's a fraction bar. So if I was to write this out like the other one, it would look like this. And so what we're going to do is we're going to keep the first guy the same. We're going to flip over the second guy, and we're going to end up with 4 over 9. Generally speaking, our pattern for this guy ends up with A over B times D over C, also known as AD over BC. And there's that. Okay, so now to dig into the meat and potatoes, now that we've done our fraction review, in under 5 minutes, we are going to go ahead and start talking about simplifying rational expressions. So each of those things that we did with fractions, we're not going to do with polynomials in the fractions. Yay! How fun is that? Okay, so to simplify a rational expression, the first thing we're going to do is we're going to factor the numerator and the denominator. And then we're going to look for anything that's the same on the top and the bottom so that we can cancel them out. As a reminder, if you see x plus y over y plus x, that's the same thing. You can just turn that into 1. If you have x minus y over y minus x, that simplifies to a -1 instead of a +1. All right, let's start factoring. Okay, this first thing, that's a difference of cubes. Okay, I can do this. So difference of cubes, I'm going to write myself a note because I forget things. So difference of cubes, a cubed minus b cubed was a minus b times a squared plus ab plus b squared. Yes, that is right. Okay, so then in this case, my 64m cubed, what do I cube to get 60? 4? 4 times 4 is 16 times 4, yes, 64. So this is 4m cubed, and this is minus 1 cubed. So I'm going to go through everywhere there's an a, I'm going to put a 4m, everywhere there's a b, I'm going to put a 1, and we're going to end up with our expression. So this is 4m minus 1, 4m squared plus 4m times 1 plus 1 squared. And so that becomes 4m minus 1 times 16m squared plus 4m plus 1. All right, that's my numerator. Blah, blah, blah. Let's do the denominator. Let's do it in darker blue. So let's see, we have 4m squared minus 13m plus 3. We're going to factor the quadratic. I'm going to stick with a more traditional method rather than doing the slip and slide. I'm looking for something that multiplies to 12 and adds to -13. That would be a -1 and a -12. So that means I'm going to have 4m squared minus 1m minus 12m plus 3. And that gives me 4m squared minus 1m plus -12m plus 3. Pulling out an m, 4m minus 1. I'm going to pull out a -3 on this one just because this guy right here is negative. So -3, and I'm going to end with 4m minus 1, and that gives me 4m minus 1 times m minus 3, and there we go. So now I'm ready to put this thing back together in my fraction so that I can simplify things. Yay, simplifying! So my top was 4m minus 1 times 16m squared plus 4m plus 1. And my denominator was 4m minus 1 times m minus 3. Whew, yay, there is something that's the same on the top and the bottom, right here. So that just turns into 1, and anything times 1 is itself, so we can just kind of ignore the 1. So we're just ignore that part, and our final answer is 16m squared plus 4m plus 1 over m minus 3. That's a mouthful. Okay, let's talk about multiplication. We're going to multiply rational expressions the same way that we multiplied fractions. We're just going to take the top, multiply, take the bottom, multiply. Except we're going to do one thing before we do that. We're actually going to factor the numerator and the denominator. That's always a good first move when you're trying to simplify rational expressions, multiply them, or divide them. Just because it makes it easier to see all the different factor pieces, so it makes it easier to cross things off when we smush things. So, all right, we're gonna just do some color coding here. Boop. We're gonna factor this guy. Hey, all right. It used to show the color, but it's not right now. I thought it was going to, so we're gonna do that guy in green. So x squared minus 10x minus 24. Multiplies to -24, adds to -10. That would be x minus 12 and x plus 2. Let's see, next one, this guy. 5x squared minus 20x. I can pull out an x and a 5, and I'm left with x minus 4. Then we've got this guy, so x cubed plus 2x squared. I'm going to pull out an x squared, and I'm left with x plus 2. And then last but not least, this guy down here, x squared minus 16x plus 48. Multiplies to 48, but adds to -16. It's not 8 and 6. Is it? Oh, 12 and 4? Yes. So that would give me x minus 12, x minus, not 14. honey, 4. There we go. Okay, so now I'm going to put all of my little factor pieces back into my fraction. So I'm going to have x minus 12 times x plus 2. And then there is 5x times x minus 4. And I can just smush these all together because we're multiplying. Gosh darn it. And we can do that when we're multiplying fractions. Smush. Let the smush commence. X squared, x plus 2. And then x minus 12, x minus 4. Whew. Okay. So now that we've smushed, let's cancel. I have an x minus 12 and an x minus 12. So those cancel. I have an x plus 2 on the top and an x plus 2 on the bottom. I have an x minus 4 and an x minus 4, top and bottom. You have to make sure they're on the ones on the top and ones on the bottom. If you've got 2 on the top, that doesn't do jack diddly squat for you. You need to have 1 on the top and 1 on the bottom. So just looking for pairs doesn't quite work. Make sure that they match up where they're supposed to be. And then that gives me 5x over x squared. My exponent rules say that those can cancel out, and I end up with just 5 over x. Bada bing, bada boom. We multiplied. Whew, that one took a little while. All right, now we're going to divide. Skip, flip, multiply. Leave the first one alone. Flippy the second one, and then smush. That's basically how we do this. So we're going to no touchy the first one. So that's going to stay as m to the 4th minus, actually I'm going to do this all in gray because I want to be able to color code things later for the multiplication piece. M to the 4 minus 16 over 2m squared minus m minus 6. No touchy the first guy, check. Flippy the second one. So that means to put the 12m squared plus 18m on top and the 4m cubed plus 16m on the bottom. And then change the division sign to a multiply. This is now a multiplication problem. Theoretically, you know how to do that. Just want to point out that one guy on top, okay, I'm going to do the first one just because he's sneaky. So m to the 4th minus 16 is a difference of squares. M plus 4, m squared plus 4, m squared minus 4. This is a sum, so not factorable, but the other guy, totally factorable. That is also a difference of squares. We've got nested differences of squares going on here. Yay! This is m plus 2, m minus 2. All right, that's what that one factors out to. And the rest of them are fairly straightforward, so I trust you to be able to do it on your own. Way to go. Whee! Because we're running out of time. All right, adding rational expressions. So we're going to, for these guys, we're just going to factor the denominators. When we're multiplying and dividing, we factor both the numerator and the denominator because we can immediately do something with the numerator and the denominator. When we're adding, we're not going to do that. After we factor the denominators, we're going to find the least common denominator, also known as the least common multiple of the denominators. And then we're going to multiply the top and the bottom of each fraction by the part of the least common denominator that it is missing so that we have a common denominator. That was a mouthful. And then once the fractions have the same denominator, you can combine them into one fraction by adding the numerators, combining like terms, and leaving the denominators alone. So, Miss Norton, why aren't we doing that like cross multiplication-y thingy like we did with the number fractions? Sometimes you are. If there's no common factors between the two denominators, that's totally what's going to happen. In fact, on that first one, that's exactly what we're going to end up doing, is just multiplying the fractions by the other guy's denominator. The problem with doing that with something like the second one, where they have some things in common, is that this means you end up having to do more counseling and crossing things off later on down the road. It just means more work on the tail end. It's where do you want to put the work? Do you want to put the work at the beginning by finding a least common denominator, or do you want to put the work at the end by then having to factor your numerator and go looking for things to cancel? Yeah. It is basically where do you want to put the work? For me personally, I prefer finding the least common denominator, but some people prefer doing the extra work afterwards, and that's fine. It's just where do you want to put it? So for x plus 6 and x minus 1, there is no common denominator there. So we're going to end up multiplying this guy by x minus 1 over x minus 1. And we're going to multiply this guy by x plus 6 over x plus 6. We're going to leave the denominator as x minus 1 times x plus 6. Boop-a-doop-a-doo. But now we have 3 plus 2, and this is x minus 1, and this is x plus 6. All right, so now that we have that, we're going to do some distribution and go looking for like terms. So 3x minus 3 plus 2x plus 12 over, and I'm going to leave this denominator in factored form, unless I specifically get told to unfactor things. 3x plus 2x is 5x. Negative 3 plus 12 is 9 over x minus 1 and x plus 6. I cannot factor 5x plus 9, so that's it. I am done. Let's make that look more 5y, I guess. There. Okay, over here. So the one that we can do a couple different ways, and we're running out of time, so we're not going to do a couple different ways. My GCF, so r squared minus 20, r minus 5 is prime. There's nothing I can factor there. R squared minus 25 is the difference of squares. This is r plus 5, r minus 5. And so r minus 5 is the same on both of them. So I don't have to do anything to my first fraction. I just have to do a little modification with the second fraction. I need to multiply it by r plus 5, because that's what this guy is missing in his denominator in order to make it a common denominator. So that's going to give me r plus 5 plus 6 over r plus 5 times r minus 5. Oops, times r plus 5. Floop. Okay, so that's looking like that. We're going to end up with r plus 5 plus 6r plus 30 over r plus 5, r minus 5, and then this turns into 7r plus 35 over r plus 5, floop, flop, r minus 5, and I can factor the numerator. So I'm going to pull a 7 out, r plus 5 over r plus 5 times r minus 5. And then I have something that I can factor, the r plus 5s, and I am left with 7 over r minus 5. If you went the other route and did the kind of cross multiply thing, it would still work out. You would just end up with more things that you would then have to clean up, which is fine. Subtracting rational expressions, pretty much the same thing as adding. Just remember that when you combine the fractions, you have to change all of the positive negative signs because of that subtraction thing. And due to the nature of time, I think I'm just going to do the first one here, just because that one looks a little weird. This is really 3 over 1. It doesn't look like a fraction, but it is a fraction. Every integer is really a fraction. Newsflash. So we're going to multiply this by x plus 4 over x plus 4. And then that's going to give me 2x minus 1 minus 3 times x plus 4 over x plus 4. So let's clean up the top a little bit here. 2x minus 1 minus 3x minus 12 over x plus 4. 2x minus 3x is negative x. Negative 1 minus 12 is negative 13 over x plus 4. And I can't factor that anymore. And that's that. That's done. I think this was our last thought. I think it was. Nope, it wasn't. There were simplifying complex fractions. So glad we saved just a little bit of time for this. Complex fractions are one of my favorite, all-time favorite things to do in pre-calculus. So what we do with this is we just look at the top, the numerator, the top half of the big fraction, and we simplify that all up into one fraction. Then we look at the bottom of the big fraction, and we turn that into one single fraction. And then it's dividing fractions. So we do exactly what we did back when we talked about dividing rational expressions. So let's get going. Blah, blah, blah. What we're going to do is we're going to just look at the numerator So we're going to do that in pink. So we have 1 over 10 minus 9 over 40x squared. My GCF is 40x squared. This guy's missing 4x, and this guy's missing 4x squared. Floop. So I have 4x squared minus 9 over 40x squared, and that's my numerator. I'm going to go ahead and write that in fractured form. So that's a difference of squares, 2x plus 3, 2x minus 3 over 40x squared. All right, let's do the bottom in blue. So 1/3 minus 2x. Remember that anytime you see something with an odd denominator, it has a denominator, it's just hiding the denominator's 1. So we're going to multiply this by 3 over 3. And that gives me 1 minus 6x over 3. And there's nothing there I can factor. Nope. There is nothing there that I can factor. I feel like I messed this one up when I copied it down. But oh well, we're just going to move on with life. So that's going to give me 2x plus 3 times 2x minus 3 over 40x squared. And then I'm going to flip over that blue, or, well, let's write the whole big thing out. Divided by 1 minus 6x over 3. And then we divide fractions by keeping the top one the same. 2x plus 3 times 2x minus 3 over 40x squared. And then flipping over the other one, that should be a 3 over 1 minus 6x. And then multiplying. And there's no common factors here, so we're just going to smush. 3 times 2x plus 3 times 2x minus 3 over 40x times 1 minus 6x. Ba-doom. We're done. Okay, this other one is also a lot of fun, but we'll leave it alone for some other time. One thing to remember about rational expression skills is they're going to come back. They're going to visit us in the future. In, sometime in this unit, we're going to be talking about rational equations and how to solve them. If you don't know what to do with rational expressions, solving rational equations is kind of like, what the bleep? And then long-term wise, we're going to spend some time just focused on looking at rational expressions when we were talking about polynomials. And then we'll spend some more time playing with rational expressions when we get to the trigonometry in the second half of the course. At that point, I'm going to assume that you know what you're doing with these, and we're not going to spend a lot of detailed digging in because, oh yeah, we already know how to do this. It'll be fine. One will be fine. One last thing that I want to just warn you guys about, common mistakes that people make when they're playing with rational expressions is that they split up a fraction over a denominator when there's a plus or minus. You can't do that. A plus b with a common denominator, you can totally split that up into two fractions, like 1 plus x over 2. You could turn that into 1/2 plus x over 2. Perfect. But 1 over 2 plus x does not equal 1 over 2 plus 1 over x. You cannot split fractions based off of the addition subtraction. You can't split them up when it's in the denominator. You can split them up with multiplication in the denominator sometime. Yeah, not really. Just the numerators. You can split up numerators, not denominators. Leave the denominators alone. Our next video will be covering radical expression skills. Yay! Rationals and radicals. Why are there so many R words? I don't know. There just are. Don't forget to go and fill out your video reflection for this particular video, and happy mathing!